How to find out demand function from the utility function? The question is, if the utility function of the consumer is given by, that is, utility is a function of two goods x1 and x2, which is equal to x1 times x2, and the budget constraint is, that is, total income, which is denoted by m, is equal to p1 times x1 plus p2 times x2. P1 is the price of good 1, x1 denotes the units of good 1. Likewise, p2 is the price of good 2, and x2 denotes the units of good 2. Then at the equilibrium level, the demand function of x1 will be, options are being given, m upon 2p1, m upon 2p2, likewise negative m upon 2p1 square, and D option is negative m upon 2p2. Okay, so what we do, we want to maximize the utility function of the consumer, which is equal to x1 times x2. Okay, to find out the equilibrium level of optimal point is for x1 and x2, what we want to do, we want to maximize the utility of the consumer subject to the budget constraint. So this is the budget constraint. Let's write it. P1 times x1 plus p2 times x2 should be equal to the income of the consumer. Okay, now we know at equilibrium what happens. At equilibrium, the marginal rate of substitution between x1 and x2 should be equal to the ratio of the prices, p1 upon p2. Okay, we know this condition from many videos. This is to say, if we have good x1 on the horizontal axis, good x2 on the vertical axis, given the budget line. Okay, so if this denotes the p1 upon p2 is the slope of the budget line. And what about MRS? MRS is the slope of the indifference curve. So at equilibrium, what happens? The slope of the budget line and the slope of the indifference curve should be equal. Okay, MRS, as we know, it is simply the change in the utility due to the change in the consumption of good X should be equal to, or rather, upon the change in the total utility due to the change in the units of good to consumer. That is to say, MRS is simply equal to the ratio of the marginal utility of good 1 upon marginal utility of good 2, which is equal to marginal utility of good 1 is this du upon dx1, the change in the utility due to the change in the consumption of good x1. mu2 is the change in the total utility due to the change in the consumption of good x2. It should be equal to the price ratio of the two goods. Now du upon dx1 is the partial derivative of the given given utility function with respect to x1. Derivative of x1 is 1, so we are left with du upon dx1 is equal to x2. Likewise, du upon dx2 means derivative of this with respect to x2. Derivative of x2 is 1, so we are left with x1 only, and it should be equal to p1 upon p2. Solve for x2, so x2 will be equal to x2 is equal to p1 upon p2 times, transpose it here, x1. Like this value of x2 into the demand function, so we will get p1 x1 plus p2 into the budget constraint. X2 is p1 upon p2 times x1 is equal to m. So p2 gets cancelled, so we have x1 p1 x1 p1, so we have 2 times p1 x1 should be equal to income, or transpose 2p1 to L RHS, so we will get x1 will be equal to m upon twice p1. That is the demand function for good x1. That will be a function of income and prices here, and it is obviously the Marshall and demand function. When the demand for a good is a function of income and the prices, we say it is a Marshall and demand function. So we have m upon 2p1. Let us see, m upon 2p1. So B option must be correct. I hope I make myself clear in this video. Thank you.